Hi guys, today I came up with another interesting problem, that is object detection using a built-in model YOLO, and also we have developed a user interface using a Flask. So this project is going to use YOLO. So you might be knowing what is YOLO. YOLO is the built-in model which is used for object detection. YOLO stands for you only look once, and this is very popular built-in model which is used for object detection. So these are the features of this capstone project. You can have a object detection using YOLO, and also you can also have a web-based user interface which is powered by Flask, or you can use any other API to create a user interface. And then you can supply images as input, and then from the images the objects are detected. So I would like to show that. So once the objects are detected, you can have the bounding boxes and also what kind of object is that, so that can be shown on the image. And here the workflow of this project is this: you are going to supply an input, that is image. Even you can enhance this project to do the object detection from video also. So I'll be showing that in the future videos. And then processing, so we have developed a user interface which will take input from the user. So you have to supply image, and that image is given as input to the model. Then YOLO model will pre-process your image, and then it will do the object detection. And even you can save your output, processed image, in a folder. You can install, you can also download this download the code from this repository. Here I've been mentioning what are the prerequisites required and what are the libraries required, and we are going to use no the built-in YOLO model. So we have a class for that, and that class automatically develops. So let me show you how to do the object detection. So here the file is created, app.py. This is the Python script file, and these are the libraries which are to be imported. So I'm using Flask, so you must be installed Flask, and also some other libraries like pill for image processing, and input output for IO means input output. And YOLO is available from the library Ultralytics. And then we are using CV to stands for computer vision, and also we want to get the files, so that's why we need to import OS stands for operating system. Here I'm creating a Flask app, so creating object to the Flask, and then we are doing the configuration. So this is the variable upload folder, and this is the path for that. The images are saved into the folder images, so that you need to create. And then we are defining a class here, and this is constructor. Within the class you have a constructor, so whenever the object is created, the constructor is called automatically. And here we are creating an object to the YOLO, so it will automatically download the YOLO model from this path, GitHub path, and that is saved into the folder object detection with this file name. So here your model is available, and we are writing couple of functions. The first function is this predict. So what it does is it takes the parameters like image, and then classes. This is no list, and then confidence level is 0.5. By default we are giving, that is implicit argument. And then if classes, if there exist classes, then we use our model to make the prediction for the image by giving those classes, supplying the classes and the confidence. Else this function takes only two parameters, image and confidence, and then it returns the result. So that is predict function. Then we are writing one more function, predict and detect, and this is taking these parameters like image, and then classes, confidence, rectangle thickness. We are doing the parameter tuning here, and text thickness is 1. And here we'll use the a free predict function which we have defined above, and then it will do the prediction, and then results are stored into the results variable. And for result in results, we're writing a loop, and once we got our results, we would like to draw a rectangle, and we also want to put a label. So what kind of object is that? For that, we are writing a code here sorry, with these parameters tuning here, specifying the color and rectangle thickness. So those are passed as parameter to this, and then putting the text on the image with the name you get from the results. And this is the color used, and also this is the font used. And then when you call this function, it will return two parameters, two things: image and then the results. And this is the function to detect an image from the to detect object from the image. So it takes the image as parameter. Within this, we are using the above function, self dot predict and detect for this image. Calling the function, then it will return the processed image. So that is about the class definition. Then we are creating an object to the class. So detection equals to detection, and then this is a root function index. So whenever you call the local server, when you browse the local server, it is going to render this file index.html. So we have written a HTML file, so on which the controls are shown. There you have to give the input and use the control to make the prediction. And then for apply detection, this is another function written. If the image is not in the request.files, then it says no file path, and then file equals request.files of image. Then if the file name doesn't exist, it says no file selected. And if there is a file, then secure file name, you get the file and then add it to the path, and then save it to the path, and then open the file converted into RGB format, converting the pixel values to numpy array, resizing the image to 512 by 512 pixels. And then we are using the function detect from image. Then it will do the detection, and again converting the output pixel values into the image format, then reading the buffer input output and saving the file in the PNG format. The file is also removed at the last. Then send the file to the this is the file type to the buffer. So when this app runs, when this script file runs, it will run the function run local server, and this is the port number used. Let me also explain you what is the code of index.html. So we have created folder templates, in that we kept the file index.html, and we can do some CSS for coding in the file styles.css. You can put that in static folder. Here I have created virtual environment and then install all the libraries. Then what is the code in index.html is, we are writing the code of HTML. I hope you guys are all familiar with HTML, how the HTML works and what are the different tags and how do you create a page. So specifying the parameters here, character set, then width and height, then this is the title of the page, object direction UI, then linking your style sheets, and then end of the head. Then in the body, this is the head. In H1 you are displaying this text, object detection using YOLO, and upload. This is also label, upload an image. Below that we are writing a form which in that adding controls, text, and then submit. Then it will show the button detect objects, then read the image, and then end of the form. Below that we want to show the processed image, so the label, then image is added, which image, the result image. And then you have the anchor tag for this button, download image. End of the script. Then this in script, what you're doing is getting the input and then fetching the data from the form, and if the result is okay, then creating object, get the result image, download image. So for that we are writing a code, and then if the image is not able to process, then it will display the message failed to process an image. the end of the script and the end of the body and end of the HTML. So let me run this file. So when you run this, the local Flask server will start, and then you can open some editor. You can open the editor, and then you can so this is a user interface. Here you need to select the file. So choose a file, then select some file. For example, I'm supplying folder from my OpenCV images. I'm pausing this image. So once the file is selected, you can see the file title. Then you need to click on detect objects. Then object detection is done in the background. Your model will make the prediction for the image, and you see these are the no bounding boxes with the object detected with, and also with the labels. So object detection is done. Then you can also download this image, and that will be downloaded here. You can also click on the image and you can see the processed image. So this is the image saved. So like this you can use YOLO to do the object detection. I hope I explained how to do the object detection using the built-in YOLO model. So that's it from me. Do subscribe our channel and do follow up the future videos.